In this lecture, we're going to talk about generics. And generics are really important when it comes to TypeScript and what you're going to see out there as you look up solutions in TypeScript. They're all over the place and they can be really confusing at first if you don't understand how they work. So hopefully we'll clear that up in this video. You have a good idea of how they work and why you're seeing some of the syntax that you see out there. And they're also incredibly useful, which is why you see them used a lot. So first, let's do a couple things in this file to make it obvious how this is working. So I'm going to create an interface called iPerson, and it's got a name and an age, just to make coding this a little bit simpler. And I'm going to create a person, just me and my age. Of course, it's 21 as always. All right, so now I've got this person. Now let's look at how we can use generics. So I'm going to create an array, and we'll just make it equal to an array like this. So if I do array.push test, this is fine right now, right? But I don't get any IntelliSense out of this. I don't get any type checking. It's just kind of, it's able to guess right now, but if I were to put in like arr.push a number as well, now the IntelliSense has no idea what this is. It's only showing me the combination of these two because it's been able to read. It knows that one's a string and one's a number, and here's my only options for what I can do on that. So this is sort of a problem, right? We really want to get better typing than that. So what we could do is type this and say this is an array of type iPerson. And now when we do array.push, it's going to expect an iPerson to be passed in. So this is an example of us using generic types from another type. So now I would know that I got to pass in a person like so. If I did anything else like a string, I would get an error. So this is the basic example of how generics work. In this case, I'm passing in the angle brackets, which you'll see them everywhere, and they probably drive you crazy trying to figure out what they mean if you've just been playing around with TypeScript. But basically, it lets you define the type that's going to be used for that type that you've defined. And there's different ways that you could use these, and it will make a lot more sense if we just create a function or class that uses generics the way that this array type is using generics. So let's do that. Let's do a function, and we'll create a function called return self. And all that this does is it takes an object, right, and it returns that object. So there we go. This is the whole thing. Now we got to define this as something. So in this case, we'll say we're going to pass in a person and return a person. Now, the problem with this is that we can only ever pass in person now, right? So I can say let me equal return self, and I'll pass in that p there. So now this works, right? But what if I wanted whoever's going to use this return self function to be able to pass in their own type and say what they're going to pass in? Now I can create my own generic here and use it here. So whenever I define a function or a class or whatever, I can add these angle brackets and then put a series of types that I want in here. So I could put more in here as well. And you can name them whatever you want. And then you can use them in the rest of your function or class. So in this case, you're going to use them like a type. So in this case, the O is going to be of type that you pass in. So the argument is going to be of the type that's defined whenever this function is called. So now what we can do is on here, I can say iPerson is what I'm passing in, right? Now if I were to pass in something that's not iPerson, I'm going to get an error and say that this requires is to be a type iPerson. Now what if I did want to pass in a bunch of numbers? I could just change this to number here. But now I can't pass in a person because it expects a number. So this is really cool. We've allowed the user of our function return self to determine the type that's going to be passed in, which also in this case determines the type that's going to be passed out, because we just return ourselves. So TypeScript knows what that type is. We can also explicitly say that we're going to return type T here. That's what this colon does. So we're going to return type T. Now, how could we use this on a class, which is how you'll see it a lot of the time that you use it. So we can say class, let's call it my list, and put a generic type on there. And then in here, we're going to have a list of items that are an array of type T. Okay. And there we go. So now we have these items that are an array of type T. And then we want to have a function add. And we'll pass in an item of type T, which we will then push onto our items array. Now this is really cool. Let's look at what's happening here. We are defining our class and saying, hey, the user of this class can determine what type it's going to be in. And then that determines what type of array this items is. So this is going to be an array of type T. And then on the add, we pass in one item. And let's see how we would use this. So let's say let my list equal new my list. And we're going to tell it that we want a list of I person. There we go. Now whenever I say my list.add, we'll see that it's looking for type I person. So this type that we've passed in here is permeating through everything else that happens in this class. So if we change this to a number, then whenever we add, it's going to say that it expects a number. I can just pass in like 24 here. And then we could just console.log out my list.items. So let's just see this happen. So we'll save it, run it, and there it is. We can add a bunch of these. So my list.add, just add more things to here. And there we go, we get 2 coming out. And then if we were to change this to I person again, we would break our code down here because these aren't of type I person. So hopefully that made sense and you can start to see how this works. You'll see this happen on a lot of the different types that you pull in, and you really need to understand what's happening here. But the key is that when you define your own, you use this variable that you create here as if it's a type, an unknown type at the time, a generic type, if you will. So you're defining that type here, and then you can use it as if it's a type everywhere else in this class. And then when the consumer of this class determines the type, it will permeate throughout that class and ensure that type safety happens on all of those methods and types and variables that you have in that class that use that type T in this case. So hopefully that makes sense. You need to just kind of go over them, use them, do this example yourself, and see how it works and see all the value that it can bring you, because generics are huge for TypeScript and really any modern language. They really help you define these types that can be more dynamic in nature, but still have type checking. So go out there, play with them, and then I'll see you in the next video.